not sampling.
I don't know if it's called.
Not on the motor. Where I see sampling rates adjusted is like on your analog inputs and stuff. If you've got an instrument that's feeding an analog signal and it's subject to noise or hiccups occasionally, rather than taking and reacting instantaneously to that value, that errant value, it can take a running average of the 3 or 4 or 5 measurements to help smooth that out. So that's the type of sampling changes you do have for that.
Well, I don't think I used the right term quite. There's a frequency at which they build the AC coming out of it.
Mm-hmm.
Right. And I know I had an application once where the motor was quite noisy. And by changing that frequency.
Oh, all right. I know the carrier frequency.
Okay.
That's what it is. And yes, you have an adjustable carrier frequency, and you increase the carrier frequency to change the audible level of audible noise coming out of the motor. So the higher the carrier frequency, the lower the noise. And actually, when you get above, you can go up to like 15 or 16 kilohertz for, let's say, for the horsepower you're talking about, the horsepower ranges. And somewhere around 12 or so, the frequency actually gets out of the range of human hearing. So you could adjust up. Likewise, if you don't care so much about audible noise, but you're concerned that you've got, like you said, the avoidance frequency where the drive is resonating with the motor. Mm-hmm. Sometimes by lowering the carrier frequency, you can filter that out.
Right. I think that's what I had.
Okay. Do you ever run into?
The one in that back second floor office.
Yeah. Do you ever run into applications where your motor is like hundreds of feet away from the drive?
What about it? I've seen some applications that I didn't care for it where they were actually driving multiple motors off this one drive. I didn't like it, but that's the way they came
well,
out.
if you've got, let's say, 3 or 4 fans that are just the only difference is they're physically out somewhere and you want things equal, I can see that. I can understand people doing that. The only cautions there are, one is the drive's amp rating has to be greater than the sum total of the 4 motors, or it could run into a situation where it overloads. That's number one. Number two, at that point you have to put individual overloads on the motor, because the drive wouldn't know if one of them is operating at 200% constantly. It wouldn't. Well, it might sense there's a high current, but it wouldn't know which motor was causing it.
Yeah,
so you have to do that.
That was designed that way.
Right, and the other thing you have to be concerned about is lead lengths, because if you're running 4 motors, you have to take the sum of the 4 motors' lead lengths into consideration. So that might add to some harmonics, some other bad issues with like ground loop currents or reflected waves. And having said that, I did want to say this drive is particularly strong at that point. You can go up to 1,300 feet. And that's why I started asking about your motor lead distances before you have to consider any sort of filtering, because it's kind of built into the drive itself with the transistors and the technology that was employed there. Again, part of that 10-year design life. So that's an overview of the EQ7. And you do have the brochure there, and what we've come out now with is a catalog which is, what, 2 weeks old, if it's that old? That's how fresh and up-to-date that catalog is.
We had it for the Easter show in Vegas, so it's unprinted, so it's right up the presses. It's got list prices for all our drives and motors are in there. Jackson can help with getting you going.
Are we going out to Vegas next to tour the facility?
Actually, at one point, I think Vegas was the hottest market in the country for HVAC, and of course, why not? With all those hotels and the boom and all that building and need for creature comfort, especially when what he didn't tell you is while that ESA show was going on, that's when the temperatures were like 114, 115 degrees outside.
Yeah, I've only been to Vegas once, and I joined the military. They had to shut down things for long. Not good.
I want to say that this is the EQ7 is the new drive we have. We have some existing drives that also work for the HVAC fan pump, and we have some brochures for there too. One of them is the MA7200, what we call the MA7200 Plus, and we take that product has it's a fan and pump drive. It also has it has the BACnet card that can be actually inserted inside. Oh, I'm sorry, you didn't pass those out. I apologize.
No, I was just gonna give you.
Oh, okay. And we have okay, it has a BACnet. It also has some things for the pump roll, like we can put in engineering units. You've got that sleep wake mode. You've got the ability to detect on your feedback whether you're at a low level that you can set a threshold level and say if I'm below this then there's a problem. Same thing with a high level. So let's say, for example, you have a transducer that goes from 1 to 100 psi, but you know that your pipes can't take anything more than 50 psi, so you never see anything more than half scale. You can actually set a high feedback threshold of, let's say, 45, 47%, so you can trip out and stop the drive and prevent it from being the cause of your pipes bursting, for example. And you've also got the ability to do some power monitoring here. So if your client needs to prove energy savings to get rebates from various power companies, things, we've got the information on there that can be conveyed and shown to prove the concept.
How does it deal? It probably presents a pretty straight load in terms of reactance on the incoming power, doesn't it? What I'm asking is, I know power factor, or what are the right terms? Your phasing of your current draw versus your voltage.
Oh yes, it's about a 97-98%. What he's talking about? Are you familiar with the? Okay, so I won't draw it out here, but you know you're talking about how the current follows the voltage form.
Right.
It's about a 98%.
So that might be something that
Or
will help people.
0.98, because I guess 1 is perfection. Yeah,
Yeah.
1 is they sit right on top. Yeah, 0.98.
That could help somebody in terms of changing over to a drive on motors, and they can get away from all of that
Right.
inductive reactance that they have on the motors.
That's one of the things. And the other thing is, if somebody has a motor, they've got a starter, and they've got an overload, and they've got an ammeter somewhere, you know, it's all combined in the drive itself. So that's another one, is just eliminating a lot of excess equipment, getting things here. If you need to, if this drive or this piece of equipment is part of a larger system, and you need to sit in one central location, you want to sit at one central location, just be able to bring something up and monitor. Well, that's all the network communications. So the drives will be passing the information back and forth for that as well. There's, I said, there's diagnostic screens, there's fault screens, there's monitoring screens on board. There's the quick start menu. There's just a whole lot of information that, but when you think about it, what is the drive doing? All it's doing is changing the speed and the voltage out. That's the only two parameters it can really send out to a motor. But when you have all that, and you're reading the card back, how much you can do with that information. It's kind of amazing to see how they really perfected and gotten the science down on these drives. And they're making them smaller footprints, larger horsepower, larger capacity, so it's progress. So it's a lot easier now to replace a contactor with a drive than it was, say, 10, 15 years ago, from an expense and a maintenance standpoint.
You guys see a lot of 200-volt buildings, 200 volts?
See some of it.
Okay.
Some of your neck of the woods.
Oh yeah, we do a lot in the city.
Yeah, I remember being up that way, there's a lot of people.
Yep, our motors are good for 200 and also the drive. It's really been successful putting in buildings.
Do you ever see things where it's supposed to be about a